Hey, welcome back. So here's a second problem we can solve using the multiple pointers or the 2 pointers pattern. It's a bit different, as I already mentioned, because we're not working from the beginning and the end towards the middle, but we still have 2 pointers, and that's really all that matters. 2 pointers moving some direction based off of a condition. So the function you need to implement is called countUniqueValues, and it should accept a sorted array again, and it returns the count of unique values in that array. And it can have negative numbers in there, but it will always be sorted. So in this case, it should return 2 because there's only 2 unique numbers, 1 and 2. In this case, it should return 7 because we've got 1, 2, 3, 4, 5, 6, 7 as far as the unique numbers. Empty, we have 0 unique values. Here we have 4 unique values, -2, -1, 0, and 1. So you can use 2 pointers to help you out here. If you do want to try this on your own, it's not, a direct copy or a clone of the previous solution. It is a little different, but we still have 2 pointers. So here's, if you want to just try it totally blank slate with 0 pointers, 0 help, 0 hints, go ahead, pause the video and just start it. There's an exercise after this video if you want to try it, and I'll have a solution after that. But if you do want some advice, some hints, pointers, here's how I would do it. This is sort of the intended approach. Start a pointer, let's do this example. Start a pointer here and another one here, and basically compare the two. Well, these aren't equal. So you could create a variable to count how many times they're not equal, how many times there's a different value. But the other thing you could do that's kind of nifty is use the array itself to store the unique values. So build the unique values at the beginning of the array, because there's no rule that says you can't, alter this array that's being passed in. You don't have to use a separate variable. So the solution I'm going to do will actually build up the unique values at the beginning. So we'll end up with a 7 right here. And then we'll end up with a 12 here and a 13. And so our first pointer is only going to move as far as index of 6. If there's 7 items, it will move over. So let me just show you an example. So if we had this array that was passed in, I would have a pointer here, let's call it I, and another one called J. And we compare them. Well, they are the same. So I'm going to move J forward, but leave I where it is. Then I'm going to do it again, compare them. Well, they're still the same. So I'm going to move J, sort of like, J is like my scout, leading the pack, or the charge, or whatever the expression is. And we look at 2 and compare it to 1. Well, now they are different. So then I'm going to move I up here, and then I'm going to put a 2 right here, just like that. So now I is going to be looking at 2, and I'm going to move J forward, and now we're looking at 3. Well, 3 and 2 are different. So I'm going to move I up 1 and put a 3 here. So I'm building up the unique values here. And at the end, I'll have all of them at the beginning, and I can just figure out how many there are based off of what index I is equal to. So I move J up again. Oh, it's another 3, so we don't do anything. We just increase J. Now we got a 4. So I'm going to move I up and put a 4 here. So now I is looking at 4. J goes to another 4. We don't do anything. J goes to a 5. Now we have 5 compared to 4. So I add 1 to J and I put a 5 here. Now we compare 5 to 6. Well, they're different. So we put a 6 right here. And now we're done. J has hit the end of the array. And this really only takes one pass through the array, O of n. And we're looking at how many items are here. Well, the way we would know that is by taking the current index of I. So I is going to be 0, 1, 2, 3, 4, 5. So that's index of I. We need to add 1, of course, because our index starts at 0. So there's actually 6 unique values. And this is one way of doing it. We don't even need a separate variable. We don't need another variable to keep track of, unique values. Now, if we weren't allowed to alter the array, then this might not be the best approach, but it works well for this exact set of circumstances. Okay, so if you want to try it using 2 pointers starting from the left side, you could also start from the right side, of course, and move to the left, but move from one direction to the other with 2 pointers. I'll have a solution after this, after the exercise.